All right, everybody. Good morning. The date is September 23rd, 2021. Welcome to another special installment of Autodesk Virtual Academy. My name is Adam Evangelista, Customer Success Manager, MC Extraordinaire, and your host for today. We have a very special guest here for today. And in fact, his name is Adam Evangelista, Customer Success Manager. I'll be presenting here today, guys. We'll be talking about Inventor API here today. And we are joined by the magnanimous, the ex-missionary, Philip Cox himself, dude. He does get a little title card over here. So thanks for joining us here today, Phil. How you doing?
Thanks, Adam. It's always good to be here on AVA.
Glad to have you, man. Glad to have you back on here. And so if you guys are familiar with either of our presentations in the past, Philip's done a lot of the Inventor API stuff, which we'll be talking about here today. And so today we'd like to kind of cover a bit of a case study for the tutorials that Philip has been doing in the past. And so kind of basing this presentation on Phil's previous presentations, we're going to kind of go through the case for using Inventor API and go through a particular application that I've been working on over the past couple of months on and off as we've got into things. Okay. And so again, thanks everyone for your patience. Thanks for being here. Thanks for watching. If you have any questions, issues with sound issues, like I've been messing with my audio, so let me know if there's any issues with that. And it is a Zoom webinar, so feel free to ask any Q&As via the Q&A functionality or the chat window if you want to put some messages in chat. There will be polls and stuff coming up on the way as well, so be on the lookout for that as well. There's also going to be surveys after this. And so if you have any feedback, if you don't want to see my face ever again, I have good news and bad news, but we appreciate any kind of feedback via those surveys as well. Okay. Let's get into this, huh, Phil? What do we got going on over here? Let's go to the next slide. What's the agenda for today? We're going to do a small introduction. So I'm going to talk a bit more and do a bit more preamble about myself and the world around here. We're going to talk about the case for Inventor API. And so I really do want this to be kind of a conversation going with you guys about what is Inventor API, why are we using it here in this particular case, and is it applicable to you as well? So we're going to focus a lot of conversation over there. I'm going to go over the case study itself and kind of talk through some of the code that I have on my end that I'd love to share with you guys. And then we'll have a quick summary at the end, and then a Q&A, and then all the other good stuff that we all come to love and enjoy. And notice there is a plug clip art over here because I'm talking about plugins today. Good stuff, Adam. Very, very creative. All right, introductions. Hey, that's me. I'm wearing the same shirt right now. This was at my buddy's graduation a few years ago, but how handsome.
I was going to say, was that today?
Yeah, this is outside the door, actually. But that's me. It's a great picture. I just updated my profile pictures with this one. But that's Adam Evangelista in the flesh, customer success manager, but oh, so much more. I've almost nearly 4 years at KETIV Technologies now. It'll be a full 4 years in December, technically. But, I've been here for quite a while. I've done quite a bit over here. I've done some support. I've done some training. I've done some account management. I see in our audience, we do have some people in my inbox that I recognize. Andy, how you doing, man? I did respond to you, so I'm glad about that. But let me know if you guys need help with anything. I'm happy to talk about any of that. We've covered all sorts of software over here, Inventor, AutoCAD, Data Management Vault, and more. So many Autodesk products to talk about, and we'll be focusing on Inventor today, but feel free to ask questions about any of this if you so desire. And one fun fact about Adam is that he's never watched anime ever. So if there's any question about that, I don't want to hear it. So please.
All right. I would say you're missing out, but I mean, you're going to watch the Star Wars Visions thing. That's kind of anime.
Oh, shoot. Yeah, I heard
that might be your first.
A lot of big names around there, Studio Trigger and stuff. Not that I would know, but okay, let's see what else we got here. Next slide, shall we? We're going to run a quick poll over here. So again, I'm kind of just curious what everyone's kind of level is coming into this presentation. Again, if you're familiar with Philip's previous presentations, right, it's largely been like entry-level API kind of stuff, right? And so I don't think I shared this with you, Philip, but you should be able to see what's, these are the poll questions coming up right here. First question is, have you any programming experience? Am I cutting out there? Do you guys still hear me?
I can hear you.
Okay, cool. So do you have any programming experience? Yes, I'm really well versed. Yes, only a little bit. Or no, I'm unfamiliar with programming. Have you considered leveraging API before? Yes, no. How easy has it been learning and using the API? Good, bad, or I don't have an opinion about it.
So Adam, I think you're showing the poll results, not the actual poll.
Oh, I see. I got you. Let's do this one more time for that engagement. I should have launched it right there. Let me see if you guys see it now. What do you guys got in chat there?
Thanks, chat, for the heads up there.
Love it, man. All right, living in 2021 right now. Okay, and so I think, yeah, most people in this industry, in this field, I assume have some kind of programming experience for sure. I'm sure at various levels as well. So I do see some good distribution there. Yes, only a little bit coming in the majority for the first question. Have you considered leveraging API? I hope it's yes if you're on this presentation, but I'm glad that people are willing to learn more as well. And how easy has it been? Just okay. That's what I feel as well. So glad to hear it. Right on. Yeah. So, that seems about right. You guys can check out the results over here. I'm cutting this off just short of a minute here, but kind of what you'd expect, right? So some people with some programming experience, yes, automation's good stuff, right? Why wouldn't you want to get involved in this? And there's not necessarily like a university course for learning Inventor API specifically. And so it is a bit of a challenge trying to learn it regardless if you're just completely on your own, which is why we're here today. So glad you're having it. You guys are among good company. So as myself as well, I'm relatively new to this myself, but I digress. Let's get on with it, huh? All right. So, learning Inventor API, why would I do that? So largely, anyone that's familiar with programming, it's obviously very good for automating repetitive tasks, right? And all the kind of benefits associated with that. And more specifically, when do you want to use Inventor API versus like Content Center versus iParts versus like iLogic, right? Inventor API is really good and automation is really good in general for highly configurable and highly standardized designs, right? And so what does that mean exactly? That means that you have a limited amount of variability and you have a known amount of variability going in there, right? And so, Philip, you could talk about this as well, right? We have various configurators for customers right now. Some people do like a lot of industrial equipment, for example. So various sizes and specs for like air conditioning units for buildings or for storage tanks need to be like X amount high or this amount wide, and they can only use this type of sheet metal, for example. Those are configurable known designs that don't necessarily have a lot of, bespoke one-off design choices.
Yeah, we usually work with clients that have kind of a large range of possibilities of what they can do, but they have a set of standards. So we're not doing custom one-offs on these projects because that's not where automation shines. And so they'll have a spectrum of different parts that can go in a given assembly and sub-assemblies and stuff like that. And so it's the ability to choose all the different configurations that is possible for their customers and be able to get a really quick turnaround with very little engineering hours input, and which is very, very valuable to the customer.
Absolutely. Yeah. I think we're all kind of chasing some level of throughput or efficiency throughout all of this. And automation naturally helps service a lot of that, right? So minimizing human error, minimizing rework, and just, repetitive tasks that don't necessarily need a lot of critical thinking per se. Right. So of course. So if you're in that range, like, rest assured, you're probably well off learning API at this point. Yeah. And one last point I'd like to make here as well is that you do get a bit more control versus regular iLogic. And so one thing I want to make clear about Inventor API is that, there is some overlap with iLogic, mind you, but working with the API and working with Visual Studio specifically, you get a bit more control over Inventor and the program and the things you're able to do versus just using the iLogic IDE Lite kind of environment over there, right?
I am always amazed by what people can accomplish inside of iLogic. It blows me away. But at some point, moving over to a full-on IDE like Visual Studio and working through an add-in provides you a whole lot easier pathway to add in complexity and to house all of your business logic. So
absolutely. Yeah, and so I was going to say, being in support, I've seen all sorts of stuff in people's iLogic, man. It's wild out there. It's not a place for children, let me
It's
tell you.
impressive. I always like being like, wait, you did that with iLogic? Wow, you're good.
Exactly. So they're not necessarily mutually exclusive by any means, but something to keep in mind. Yeah, you get a bit more control with API for sure. When would you not use API in particular is another good question that comes up, right? So we've mentioned it already, but like bespoke one-off designs typically aren't things you want to automate, right? If you're early in the process and you're kind of doing a lot of kind of free-form stuff where you don't necessarily know all the unknowns that are going to be involved, there is still a lot of variability that's not known or cared about. Obviously, you can't automate the things you don't know about quite yet, right? And when I was thinking about this earlier, I was like, okay, well, prototyping, that early stages, kind of probably wouldn't want to automate that stuff, but we do have stuff like generative design out there nowadays where it does let you iterate through various prototypes using kind of some automation essentially, right? So it's not necessarily that you can't use automation in your early prototyping stages per se, but you do have to kind of pick and choose your battles, because even generative design requires some constraints and known variables to actually automate and work with, right? And so if you want more information about generative design, there's a whole another can of worms for sure, but rest assured that's probably not where you want to be spending a lot of time if you're trying to automate customized stuff like this. Okay. And of course, opportunity cost, right? With the time spent learning and automating a process versus just designing it yourself manually, right? It's obviously going to be a balance there. And in that regard, Inventor and iLogic are also just as easy to learn as anything else out there, right? So why not just use the tools you're already familiar with? Something to consider, okay? That said, right, so now that you have an idea of what problems are there, what problems aren't there, we'd like to talk about a bit of a case study that I've been working on. Again, I've been talking about this dang keyboard project for months now, but it's again, a very good example, right? If you're not familiar with keyboards and mechanical assemblies like this, keyboards are highly configurable assemblies, right? They have cases, they have backplates, they have switches, which are all come in standard sizes. They come in standard materials, layouts, components from this type of switch or that type of switch. Something that you don't necessarily need to model and do every time, right? And so that's something you could configure using Inventor API or some kind of configurator, for example. And that's why we're doing it here today. So there's a limited amount of variability and known parameters that we could end up putting in here ultimately, right? This is something versus like artisan keycaps, which are specifically like bespoke custom things, right? Most artisan keycap makers, they're sculpting in some kind of secondary 3D program, mind you, but you could imagine that you don't need to automate the sculpting process per se. However, if you wanted to automate something like, oh, I want this cactus to have 7 ribs instead of 10, or 7 instead of whatever amount, you could possibly parameterize that. And that's another kind of concept to keep in mind as well, but not the focus of what we're doing today. We're configuring the mechanical assembly of the assembly itself. They're not terribly complicated things, keyboards, right? But there are a lot of repetitive tasks involved in there, right? Even with like 65% keyboard, you're still talking about like 70 instances of a keycap to be placed in various places on there. And you're talking about multiples more constraints if you're going to be fully constraining all of this stuff as well. Okay. And in reality, it's not that much time, right? You could probably get this done like within an hour, or maybe just a bit more than an hour, depending on what you're working with, honestly. However, what I'm promising you with automation and API right now is that we could reduce this hour, not just for this one assembly, down to probably less than a minute to fully constrain and place all 70 plus components inside of a backplate, right? And I'm promising that you could not only just automate that for this one solution, but you get to automate that for everyone else with the add-in. You get to automate that for all future designs as well. So you're solving it not just for the present, you're solving it for everybody, and you're solving it for the future as you move forward. Okay. I see a lot of flashing notifications. Let me double check what's going on over here. Yeah. So, okay, cool. Looking okay. We got any Q&A? I'll come back to that, Eric. Thank you, though. All right, process. So I do want to talk a little bit how I landed here at this particular API process myself over here, because you guys might be going through a similar thing as well, right? A lot of this started, right? I started out, I wanted to make an assembly. I was lonely last year. I was by myself. I was like, I'm going to spend money. I'm going to make my own mechanical keyboard, and maybe I'll use Inventor to do it as well. I'm like, okay, I'll assemble a mechanical keyboard in CAD. Great. Right. I started with, as you might expect, right? I mean, Content Center is really cool if you want to just kind of standardize keycap profiles or standardize switch profiles and stuff like that. And you could use arrays to, kind of simplify the placement of the stuff over here. But you can see here in this picture, I actually gave up at this point because I didn't want to keep doing it. And I was like, it'd be even sicker than Content Center and arrays. Let's learn some freaking iLogic, dude. Let's learn how to do iLogic. And using iLogic and some basic scripting stuff over here, I was able to place, the components in an ordered fashion so that they could get placed accordingly over there. This is actually shows up in some of my previous AVA recordings if you guys are curious, but check that out for sure.
Adam, at this point, what was your experience level with iLogic going into?
It was completely nil. Outside of the horrors I've seen in support and stuff, I was just like, I'm not very familiar with object-oriented programming, for example. I've done like some MATLAB and some C in the past, mind you, but like not a lot of object-oriented, let alone automation in iLogic, for example. So it's pretty new to it, but even with the documentation and the tools in iLogic, you could get pretty far, as people do, right? As you've commented. But it is very approachable, for sure, right? And so again, that was just to place these keycaps in a very ordered array and fashion, right? And so even this isn't an ideal solution, I don't think, but moving on to the rest of the assembly, right? I'm like, okay, well, I want to place, more parts. I want to kind of make this a bit more scalable and stuff. And that's when I started looking at Visual Studio and API, right? In particular, I needed to make some center points that ended up in this particular one, but I wasn't able to access like certain object types in the iLogic environment where I needed to get like edge loops to place center points and stuff like that. And so that's when I started getting into Visual Studio and API, right? And my process for that specifically, right? You obviously have to know how to do the add-in, which we have a video for as well. How do you interact with part files? Because it's still a bit different than what you'd be doing in iLogic, for example. Logic and loops are a bit more robust inside of Visual Studio, and understanding how to interact with assembly files also comes along with this as well. So this is where a bulk of my time ended up being spent, right? Is just how do I work with the API and how do I do programming and stuff, right? Great stuff. And not that complicated, but we'll talk through this as we get through our samples over here. Just to reiterate again, this is again 70 plus unique instances placed and constrained within like a minute or so on an applicable part. Not bad. Right, so kind of a good time, and that's kind of what we're working towards over here at the moment. Okay, take another pause over here. I'm gonna pull up my. Oh, actually, that's about it. Any comments on that, Phil? How are you feeling so far? Having a good time?
Yeah, I just it's impressive to me the speed at which you were able to get up and going to get to the level of success. I mean, not to just pay you compliments, but.
Oh, you're too kind, Philip. Pshaw. Philip has helped me a lot in this recent project as well. So definitely deserves some thanks as well. Okay, so let's see what we're looking at over here. So just to get into things, right? This is kind of where I first had to pause, right? I was like, okay, well, I was actually trying to use like UCS. This is a keyboard assembly for the Ramakara, if you're familiar with keyboards and stuff like that. This is the back plate, so it's just a metal backing with a bunch of slots in it so that you could slot in your actual key switch, and underneath that's going to be the PCB, which I didn't model here, but I still wanted to represent the individual switches on this assembly. And you can see I got pretty far where I was like, okay, well, I could place this guy, and if you're smart about your work points, you could place UCSs, you could use constraint to UCS to kind of simplify the constraints and clicks that you have to do, but you could still see it's quite a number to go through and do it still. So I'm like, all right, well, I mean, we're smart, we could do this. We could find something a bit more interesting to do. And so in terms of approaching the problem, there was a very specific thing I needed to automate, right? In this case, it was placing the center point around an edge loop over here so we could place an individual point. And then we use that point's information to then constrain the component to that point, right? So that's the specific thing that we're trying to constrain over here. And there's kind of a mix of both assembly and part level interactions that we have to consider over there, right? And so I went straight to Inventor API, and I'm going to start with a simpler example right here, for example. So like this guy right here, I have a very specific backplate. Imagine you're trying to make like a 10 keypad or something like that, or starting out really small. Great, I have a few slots, I have a few loops I want to implement. If I wanted to, I could do manual, center point at a loop of edges if I wanted to here, okay? What I am going to do, however, I am going to pull up one of my cool rules over here, right? So come out over here. This is just a kind of event, right, for button press specifically. So when I press OK, it's going to execute some code I already have in Visual Studio. And when I go ahead and click that, it's going to prompt me for a face specifically. So like I click on this face, for example, and it's going to run through and it's going to automatically place each of those center points. Sorry, Philip, were you going to say something?
I was just saying, I was noticing your tooltip when you clicked on the thing needs a little editing there.
I literally just edited that before this presentation, and I have not saved it yet. But yeah, so effectively, right, it's a few clicks just to place all of these individual work points, right? Pretty snazzy. And you can imagine doing UCS constraints off of this in a little bit, which we'll get to. But yeah, let me look at Visual Studio now, right? So that's great. That's a great easy way to place a bunch of center work points. What does the actual code look like in here? Well, let's make sure we open up the right file over here. So project solution, I'm working with the first one over here. So what exactly is happening in those button clicks? I'm glad you asked, right? We have a form. This form has an event handler associated with this button that comes up in the DLL or in the add-in for Inventor. And then this is the sub for that particular button. And this is the code that runs after that button click, right? And so to start off, this code, I'll make sure to make this available in some form so you guys could follow along, but I'm not going to be doing live coding. So just take it all in for the moment, okay? We start this code with some, I've been calling them initializations. I don't know if that's the proper nomenclature by any means, but you'll see this in a lot of this Inventor stuff where you have to declare the part document, you'll have to declare the part definition. And since I used a bunch of work features and matrices, I had to also call out transient objects and transient geometry. Right? This is all stuff required to access these objects and work with these objects as we get into the rest of the code. So you could take it at face value. I can't really say much more about the individual enumerations and stuff like that from there. But yeah, we needed all this stuff. That's what this is over here. This first bit of code over here, this me.visible allows the dialog box to disappear. And then this line right here allows user input for a face selection, right? And you can see I did edit this so it could show up, but I have not run it out and saved it properly. This is some syntax that you could see over here as well if you just hover over the actual command, right? And so this is just simply a command that allows the user to input a face, and the selection is going to go ahead and fill out a face object for us. Okay, I had to get Philip's help for this specifically, I recall, but once you have that, right, it's going to populate this face object, right? And if you're familiar with object-oriented programming, like this face object is then going to have a bunch of properties and methods associated with it that you could then use in the rest of the code. So for that particular face that we chose, this as called as an O face, right? It's going to go into an if loop. And in this if loop, it is going to iterate through all of the edge loops inside of the face so that we could go through, add it to an edge collection, and use those edge collections to populate a work point at a centroid specifically. All right. I'm going to take a moment there because I kind of just dive straight into that for loop over there. But does that make sense to everybody? I'm essentially starting out with a user input for the face. The face has a bunch of collections and properties associated with it, such as its edge loop collections, right? So it's already aware as an object what edge loops are inside of it. And I'm using this if loop to look at each of those edge loops inside of it to place a at centroid work point at each of those faces, right? Nothing too crazy. We're still all here together. And so again, this isn't too crazy. Again, I think like this part at the beginning is kind of the weird one for me about like syntax and stuff, right? Because I mean, what initializations do you need? And like, what are these application ones over here? And moreover, how do I know what properties are in a face object to begin with, right? And so before anything else, like if you have any questions about Inventor API, like there is very specifically a lot of good stuff available in the documentation. So if you have any questions whatsoever, check out the Autodesk Inventor API help. There's great documentation inside of there. And under programming interface, under API reference manual, under objects, you could go down and you could start looking at various stuff that you may be interested in, right? So like face, for example, face is the object that we selected and took with our user input, right? That's going to have all the stuff you could do with this. And inside of here, right, you have edge loops and edges that you could then access off of that object type, right? That's kind of the whole song and dance with object-oriented programming. So you'll probably spend a lot of time here in this documentation, but I'll link that later as well if you guys are curious, or right now, because I could do it off of the host. There you go. Okay, so any questions about this, Phil? You want to mention anything here specifically?
Yeah, just that, kind of learning the breadth and depth of the Inventor API takes time. And there will be, it's just kind of a process of, I have a problem. I think I should be able to do this. Let me look up the documentation. And sometimes even that leaves a little, like, some holes that you have to kind of explore and see how things work. Using your Google Foo to see if there's a lot of people who put up examples, the saints of the API, world, where you can look up and they'll also give you hints about how to kind of solve those problems. And then once you solve one problem, you kind of have that example base in your code that you can refer back to. Because I mean, programming, when you're programming something new every day or something like that, you forget exactly how to do things, even if you've done them before, and you need that kind of library to refer back to.
Exactly. Yeah. And so you can see here too, I have a lot of commented stuff from other, like, just threads that I had over here in Scratch, but we'll talk about that a bit more. So let's jump back into Inventor over here. Once I have this part configured with all of my components and stuff like that, I'm actually going to run another code at the assembly level specifically. And there is a reason for that, which I'll get to. But I'm going to open up another bit of code over here. Open solution. And so this one is specific to the assembly environments, and this is specific to placing the actual components in here as well. And I do want to just swap out this small comment over here. I told myself I wasn't going to do anything live, but I'm going back on that right now. So
live programming.
So I have a sample right here set up, and I'm gonna flip a switch right here so I could run it on the appropriate file. So right here I have two component placements over here, two component occurrences in assembly. I'm going to run the second one instead of the first one, so we could just look at the small example first, and then I'm going to run this out. Start Inventor API.
So if you wanted to, Adam, how could you maybe do that programmatically?
I was asking myself that, but then it was like 2 o'clock last night, and I was so that's honestly, I wish I had spent more time on this particular section, right? Because I'm hard coding this particular instance into the assembly right now, right? Which is fine, but you want to make it as automatic as possible, right? Can you speak to that? I'm not actually sure what I would need to just get the components to come up here.
So, I mean, specifically, you could have a drop-down menu, a combo box on your user interface that would allow you to select the different asset files or model states or different things like that that you're pulling from. Going a little deeper, there's a lot of different ways to solve these problems as you make your solutions a little more elegant and kind of able to handle different scenarios.
Absolutely.
So you can have a text box where the user inputs, or you can do a open file box where they go and pick the file they want, things like that. So
that's a great point. Yeah, and so one thing we should definitely spend some time talking on is just like forms in general and how that all comes together. I had originally conceived this idea, which is with using model states and a pull down specifically over here. And so this is the code that we were just looking at. It's in the assembly level. It's going to pull in that particular backplate that I just annotated out, and it's going to place key switches at all of the appropriate points that I need. What type of key switch am I going to use? 3-pin, 5-pin, maybe a cherry stem. Who knows? World's your oyster. Let's do 5-pin for fun. I'm going to click OK. It's going to run all that code, place that part in, and lo and behold, it's able to place a component at each of those individual work points like we need it to. Not too bad, right? And so again, this is, not terribly hard to do, to place all these individual components, right? But if you have to do this like a dozen times over and, over a course of an hour, it's kind of a pain. And see here, there's some trouble because I do have the origin point still in that particular selection as well. But, that's okay. Perfection is the enemy. And that's what I always say on these presentations.
So Adam, it looks like you got a question on the placing
yes.
of switches.
Yeah, so is the placing of switches utilizing the custom UCSs that you have defined, or are you constraining to the work planes? Oh, that's a great question, Jeff. Let me jump back into the code over here. So my first conceit for this project was that I was going to use the UCS to UCS constraints to just automate this actual placement. And you can see actually these guys aren't actually constrained from the get-go, because these aren't actually constrained to anything. They have UCSs, but that was part of the original development of this part file. Let me jump back into the code and we could say exactly what's going on over here, right? So same thing as before, this is the event handler. And if you're curious, this is what the actual form looks like. We'll come back because I do want to talk about those combo boxes as well, but let's come back over here first. This is the event. This is some of the initializations. We're calling out the assembly documents. We're using transient geometry for work features, of course. And we do start calling in some matrices specifically, which these matrices are ultimately going to be these kind of points that we use to locate and orient things throughout this particular process. So there is a origin point over here at the matrix, right? So set translation to the origin, for example. I have the actual component coming in over here, a part definition, so I could access the different part definitions underneath there, right? And this is the kind of main meat of the code over here. So for each work point in that particular part that we just placed in, OCC dev, we're going to iterate through all the work points and do a bunch of stuff at those work points specifically, right? So at this point, I actually locate a secondary matrix, so a secondary point to set a orientation, which is a rotation in this case for matrices and yada, yada. There's also a translation over here where it's going to be actually accessing that original work point from the original part, right? So that particular center point loop, it has an X coordinate over here, it has a Y coordinate, it has a Z coordinate, and I'm moving these secondary work points onto those work points on the original part now, okay? So it is similar to UCS specifically, but what it's really doing, it's simply defining a point and moving one point on top of another point. So this isn't technically constrained at this point. And then down here is where you actually get the add function, right? So I'm adding in this particular part. And just a heads up too, I know the API for 2022 is relatively new, and model states in particular are a bit of an unknown to a lot of people, I think, right now. And so after some scurrying around, I found that you were able to place an IPT at a particular model state using this bracket, this caret notation over here. And so these are actually the names of the different model states within this particular part file. Okay, so that's what you're seeing over here. But depending on the value of the pull down, which is what this combo box value is, if it's equal to 3-pin, it's going to place in my 3-pin model state, 5-pin model state, cherry stem, cherry MX model state. Okay, and that's just a regular if loop or if catch kind of thing. You could use a switch case there too, but it's not a huge deal with this many options, I don't think. And so, yeah, I was thinking about this before the presentation too, is I know specifically in iLogic, there's like there's an input argument for the kind of add occurrence where you just call out grounded or something like that to just make it grounded at this particular point. But you see, this is simply just taking this component, adding it to this particular matrix over here, and there's no other constraints applied. Do you know if there's like a grounding like argument I could put in here, Philip? Or
yeah, that's usually what we do when we do our configurators. Is there's not a large need for constraints. They just want the things put in there and stuck where they're supposed to go. And so we'll go ahead and just place and then ground.
I thought that was a really interesting point. Yeah, reviewing all of our documentation and stuff like that. Yeah, because UCS to UCS makes a lot of sense, I think, on an intuitive level for us, right? But if you're also just moving it to the same point, it's already oriented, you don't really need more constraints because that's just going to add extra complexity, right? Which is actually what the previous iteration of this code was. So I got rid of that. I just had it placed point to point. And is there like a specific grounding input I could put after matrix 2, or is that just another line that I'm just not aware of?
It's just another line that you call out. If I believe so, it's we go ahead and ground stuff on the second video in our series of.
Yeah.
So You can kind of look up there. Off the top of my head, I'm forgetting it, but I'm guessing that you could just, off the occurrence 2, you can just hit a dot and scroll through and there will be a ground command. So there's a lot of what you do when you're programming is exactly. You're like, oh, there it is.
There you go. Okay. So
and then you just set that to true.
No live programming. All right, get me out of here. Okay, so all right, so yeah, that's just the kind of a word to the wise. Yeah, I thought that was really interesting about the automated assembly generation. There's not a lot of using of the constraint specifically. We're more concerned about positioning it and then grounding it for simplicity's sake and just maybe for our own sanity, it appears, right? So that's how we got here specifically, right? Okay, and then I also talk about the combo boxes over here. So the other nice thing about the Visual Studio in particular and this stuff is that we can make these dialog boxes really easily. And this particular one has a pull down, right? If you're not seeing this, I think it's view and then toolbox. Yeah, and then coming over here. Oh, it's because I'm running the code still, which I don't want to crash. But
they don't want you editing the form while running. I don't know why.
Yeah, fair enough. Okay, and so this is a pull down. This is the type of object you could input into your dialog boxes, and it's more on this side of things than it is on Inventor, I would say, though. But that's where these extra values come in and help populate stuff as well. Interestingly, you could also set a default value, which is what this other private sub is for, but I digress. Any other questions or comments on this, Phil? What do you think?
I guess, does chat have some questions? We'll give some time here.
I don't think we got anything there.
Okay.
Let's see.
Yeah, I like the amount of business logic and complexity that like these things can be added to is pretty large. And so this is a simple example that then you could build on. And a lot of times when you're designing these things, you're weighing the ability to handle many different types of problems. So keeping kind of your solution set open-ended versus like drilling down and saying, I have this specific thing I do 50 million times, and I want my application to solve it very specifically. It won't work on anything else except this task, but I do that task enough to make it worth fully automating. And so that's kind of here where this tool, I mean, it can take any surface that has, square edge loops in it and put a work point in the middle of it. That can be used on a lot of different things. But if we were to make a very customized app specifically for keyboards, we'd sacrifice kind of some of that flexibility for a lot of business logic specifics and standards.
Yeah. It's a lot of interesting give and take for sure. So a lot of cool stuff kind of coming through. There we go. And so, just to prove the proof of concept over here, right? So obviously I could go into another part with another kind of, am I cutting out there again? I'm sorry, guys. Oops. Okay. Are we still there? Are we still in?
Yeah, I can hear you.
Oh, geez. Okay. I think because I'm not sure why that's lagging, but yeah. So yeah, obviously this is a part file, right? And so going into the tools, I could call in my same add-in over here, and I should be able to call in, and this should be able to populate the same edge loops because those are specific to a face object and a part object, and it could go through and do all that stuff there, right? And then, it stands to reason that now I could go to my other code, I could place in the other part, and now if I want to place components at center points within a part, as long as the part has these center points, I'm pretty much good to go, right? And so that's how I got to that original picture over there. And yeah, I mean, there you go. So let me see if we have anything over here. Let's see, still good. Okay, great.
Got a question from Jared Angulo.
Jared Angulo. So on the topic of grounding versus constraining, is grounding preferred in this case because the positional logic is contained within the code itself rather than relying on Inventor to set up? I would argue, yeah, exactly. Because, like with the constraints, right? Constraints and a lot of tools in Inventor require a series of inputs and outputs, right? And not necessarily inputs and outputs that we're interested in as designers per se, but it is stuff like, oh, we need a point and a direction for this thing to point so that we could orient it properly on a UCS or something, right? And so by taking that step out and just having the position being the important driving factor, right, we end up not having to worry about the additional requirements that these Inventor functions require us to have, right? So if you want to constrain, face to face, you obviously have to check for two faces. You have to make sure that they're, not constrained against each other and stuff like that. And that just becomes an extra headache to balance the extra needs of the constraint functions versus just a single line of, I'm going to ground it at this exact position and this exact orientation, right? And so the same thing could be said outside of automation too, right? Where grounding is sometimes a good option because it's simpler in general.
Yep, just simplifying because we don't need the additional information.
Right. And okay, and then here's a good question from Jeff as well. So Jeff Miller, I understand the value of writing code in Visual Studio, but would it not be possible to access the full Inventor API using straight VB.NET code in the iLogic code environments? Follow up, when do you decide to write code in Visual Studio versus iLogic? I know there is, correct me if I'm wrong, Philip, I think you said that there was like copy paste VB.NET into iLogic IDE, is that right?
Kind of. So there is some difference, and we kind of go into that in the video series that we've done before of code from iLogic to Visual Studio, but it's not that much different. However, the IDE of Visual Studio kind of allows you to do more object-oriented programming, and I know Adam, you've used that term a little bit today, but really when you get into real object-oriented programming, it's using classes and functions and that complexity that iLogic struggles with a little bit. You can do some of those things, but it's a little less designed for that. And so when the business logic complexity starts to go up, that's when you really should look into switching from iLogic to using Visual Studio or a different IDE.
Yeah, exactly. And I think that's an interesting point, right? Because they're not necessarily like mutually exclusive. I don't think there's ever necessarily a hard line between iLogic and then VB.NET per se.
Yeah, and interestingly enough, like in the times we use add-ins, we're also using some iLogic rules inside the parts. And that's another thing is if you do it all in iLogic, those rules are kind of encapsulated in your part files and assembly files. And sometimes you don't want that.
Right. Yes, there's really interesting event triggers in like the iLogic environment from what I was using recently as well. But it's an interesting conversation. And so I'm hoping this is convincing you guys to, to look at the API more directly through Visual VB.NET or so. Yeah, okay, great. So what else have we got over here? Yeah, well, I guess, I don't know, you guys want to see the full assembly over here? I guess we could do that because well, I guess let's talk about the rest of the code here. I don't think there's anything too crazy. Oh, we already did that, my bad. All right, any other comments, Phil? What am I missing here? Am I crazy?
We can kind of talk about how they can kind of follow your steps and get to this point if they were wanting to.
Perfect.
I'm trying to think of.
I'm going to crash out of Inventor over here. Yeah, I'm going to crash out of Inventor over here. And so we looked at this code, and again, I'll try to make this stuff available for you guys in the future. And if you recall at the beginning as well, I had it such that the place component, right? I have two lines here. One's commented out, one's not over there. And this one's for the original key plate. But I guess other interesting stuff here too. I have some scratch in here, just some, there's a lot of trial and error in this stuff. So, I mean, model states I still don't fully understand, so probably requires a closer look in the future. But yeah, okay, let's go back to the presentation. Let's see what else we got going on here. So just quick summary, right? I mean, I think APIs pretty available to and applicable to a lot of different situations, whether you access it through iLogic or Visual Studio, what have you. I don't care. You do still have to consider your problem, right? I mean, how configurable is your design, and what's the investment cost over here? And for me personally, it's been a lot of just kind of emphasizing the process and understanding the systems involved over here. And not to dismiss the myriad learning resources available for you guys. I personally was following up on Philip Cox's series over here on getting started with Inventor API, available on our KETIV YouTube channel. And this will also go through a bunch more code, very specifically about setting up the add-in, for example, creating and using a specific part functions, using parameters inside of API, and then also the drawing view automation, which is probably the biggest thing that we talk about a lot. One of the bigger things we talk about for sure. I've also made reference to like Content Center AVAs, where I learned how to use customized Content Center. There's a whole automation playlist, and there's also the API documentation. I'm not sure the best way to send you guys all these links, honestly. I sent you some YouTube questions. Okay, thank you. Does it help with performance if you ground components or after fully constraining them?
Believe so. I'm not 100% sure, but I know constraints can slow down.
Yeah.
Things so.
Yeah, because yeah, definitely. And I guess just to speak to that, right? The constraints. I mean, you would probably do one over the other. Like if you fully constrain something and then you ground it, I don't think that's really helping you any which way, honestly. If anything, that's just adding an extra condition to your piece. But you might want to ground it versus just fully constraining it without fully constraining it, I suppose. But
well, I mean, it just kind of depends what you need to do on it. Like if you're having a piece that you want to be able to rotate and you're not going to want to ground it. You'll want to put the specific constraint along the axis there.
And that's actually an interesting case for, this is completely off topic, but like joints, and most people use constraints in Inventor assemblies, but joints are specifically about allowing for some movement if you do need the parts to move while being locked in a particular type of motion, like a rotating cylinder joint or something like that, right?
Bringing me back to my Fusion 360 days with joints.
Yeah, Philip's been all over the place, man. He's quite a traveled guy. And so I'll come back to this, and I'll link this during the Q&A. So let me just get out a few more announcements over here. We talked about configurability and kind of different automation solutions for a keyboard example case study over here, right? And you could expand these possibilities to a lot of larger projects, which is what our automation team and Philip does in most of his time here, right? And do you want to talk about this actually? Do you want to give it a go?
Sure. So kind of like I mentioned before, the width and breadth of things that can be solved. Adam talked about, doing air conditioning units or water, tanks, or, there's a lot of different things, and everything can be helped through automation. It's just kind of, the problem is identifying those problems where you're going to get the most bang for your time spent automating. And that's kind of what our team does. We have portions of our team that, like me, work on the actual projects. We have architects and, pre-sales guys that are happy to sit down with people and work through potential things. But that takes it's a skill kind of on our customers being able to identify, saying, hey, like this is something that needs, I see potential that, we're doing this and it's wasting this much time. We could do it a whole lot quicker. And so if you're ever wanting to reach out to talk about kind of some of these possibilities, feel free to email me. Adam will put my email there on the slide. And I'm happy to have, a 20-30 minute conversation and kind of just explore some of those ideas.
Yeah, thanks a lot. Yeah, and so we have a whole team dedicated to this sort of stuff. So if you have any questions, I noticed a few familiar names from our support queue, for example. If you have any more questions about any of that, feel free to reach out. We have a Q&A slide. We have support material, of course. If you have any questions about, want to email us or call us, feel free. And at this point in the presentation, feel free to take a screenshot of our support info over there. But if you have any questions, we are open to discussion. We got some time out here, let me know if you have any other questions over here. We got Jerry Burns, likely would use constraints instead of grounding if you need positional reps. Excellent input. Thank you very much. I noticed Inventor 2020 or 21, they took out the VB and you have to go and download the VB Studio to use it. Are they planning to remove VB from Autodesk Inventor? I'm not sure what that means. How does that go, Philip? Do you have anything for that?
I think he's referring to maybe the language in iLogic or maybe a specific different thing. I don't have a crystal ball for the future of what Autodesk is planning to do there. Most of my time is spent with Visual Studio, so yeah, I don't know.
I see. Someone in chat also mentioned he's possibly referring to VBA specifically, which is an interesting. I'm not. Yeah, again, we're not really sure what what the future holds for VBA per se. My apologies. And then also from Eric, yeah, joints over constraints because you can use the one joint. Maybe we should have an AVA on joints, man. Joints over constraints because you could use one joint instead of needing two or more constraints. It's a good resource. Is there a good resource for using iLogic to place joints? Oh, that's a good question. Yeah. Would this be something you would need to add to names and edges? Possibly. Yeah, if you're familiar with like trying to access like constraints through the iLogic environment, there's a lot of like naming edges and calling out faces to input into your constraint commands. I'm not sure. Do you know if there's robust stuff for joints specifically in iLogic and or the greater Inventor API?
I haven't worked with joints a whole lot in the API. It would be a good thing to look into in a future AVA, maybe.
Yeah, and I would also just search, on the Inventor documentation. If you could find the objects over here, then you're usually, in pretty good standing for what you need to do next over there.
Mm-hmm. That's a good first stop. Like, oh, I want to do joints. Yeah. Let's go look at it.
Yeah, not to brush you guys off, but yeah, definitely check out the documentation, man. It's good stuff. So, all right. So any other questions or comments over here? I'm going to hold out. Yeah, so I mean, that's all right. Well, feeling pretty good. I guess just to convince everyone that it works. I mean, I could show you guys the finished component over here. Again, I wish I would have automated this a bit more so I didn't have to, go through and do something silly like this, for example. But if I run this, I could start this and we should be able to fill out the entire keyboard as we need to. I think it was a VBA add-in that I may be referring to. Oh, really? Is that gone in 2021, you were saying? I know that tab's still there. I guess we could look when we're in Inventor right now over here. Give me a moment. Again, we're technically not, cognizant of what the future intentions are with VBA by any means. I know a lot of old documentation refers to, under the tools tab. Did you ever use VBA at all, Philip? I know working with Eric, he routed me through VBA a few times, and
not a whole lot. My background kind of didn't come through there. I was mostly using, different programming languages, C#, VB.NET, C++ back in the day. I told somebody that I C was the old language, and they laughed at me, and they were like, "You haven't used Fortran." So.
Yeah, I love that, man. One of my old, I had an air quality class where we did a lot of MATLAB and stuff. And depending on what quarter you got that professor in, he would either teach you Fortran or MATLAB. And I was like, but I think he had to stop doing Fortran after a while because no one wanted to learn it. And then he, talked about punch cards and stuff as old people do.
So maybe one thing that might be useful for a future AVA, I've noticed that we get a lot of questions kind of what's the boundary between iLogic and, doing an add-in Visual Studio or, VBA versus, VB.NET or things like that, would be kind of a look into object-oriented programming with creating classes and methods and functions. And how to use that with Inventor. And some looks in that. I don't. If that's something that's interesting to you guys, let me know.
Yeah, just literally let us know. I mean, we take a hard look at all the suggestions that come through over here. So, and I guess just to emphasize too, the VBA editor is still in here. I mean, as far as I know, you could still put stuff in here if you really need that. Jeff Miller, definitely interested in that, Philip. Write that down, dude. Jeff Miller's super down for that. And then who is this? Could we able to merge two PDFs from different drawings into a single PDF using VBA and Inventor export object model in Inventor? I don't know. Is that something we can do? Can we merge PDFs through VBA and the Inventor object model?
Never thought of that. I know there's a lot of applications built around PDFs, but the Inventor object model, I'm not sure exactly what he's getting at. Like maybe pulling out the tree, like the object model, and doing something there. I guess maybe more clarification.
Yeah, no problem. Okay. Yeah, so there's definitely a lot of interest in some more object-oriented stuff for sure. And I hope you guys appreciated this, even just as like a starter beginning stuff for getting involved in this. So hopefully this will be immortalized for the future as a good starting point for anyone looking to learn more for sure. VBA editor. Any other questions or comments, guys? I know the VBA editor is still an Inventor for sure, but I don't know if there's additional add-ons to be concerned about, Eric, unfortunately. Yeah, I think that's about all I got, boys and girls. I'm going to link you the automation playlist because there's a lot of good stuff on the automation playlist as a last farewell over here. Definitely check that out. This is on our YouTube channel. This recording and the relevant files will be uploaded to the website as well shortly afterwards. So keep in touch, man. We'll be around. I mean, some of us will be around. But feel free to reach out if you have any questions or concerns. And dude, I just want to say, bottom of my heart, thanks everyone for watching. Thanks for all your patience over the months of being the AVA host over here. Thank you, Philip, for being on. It's been an absolute pleasure presenting as the host of AVA over here. And hopefully we'll cross paths again soon, man. Have a good night, everybody. Take care and have a good week. Bye all.
Thanks, everyone.